Have you ever been shopping for an SSD and just been completely baffled by the prices? You see two drives, both the same size, but one costs a ton more than the other. Well, a huge piece of that puzzle is something called endurance. In this explainer, we are going to demystify all that tech jargon like TBW and DWPD so you can finally understand how long your drive is actually built to last.
I mean, this is the core question, right? You're looking for a new 1 terabyte drive. One is $50, the other is $250. It feels like a trick. Is the expensive one just a total ripoff? Or is that cheap one going to die on you in a month? Well, the truth is, the real difference is almost always endurance, and we're going to break down exactly what that means for you.
So here's our game plan. First, we'll get into the big mystery of why SSDs wear out in the first place. Then, we're going to decode those super confusing acronyms and take a peek under the hood at the different memory types. That's going to help us solve the price puzzle, and then we'll get really practical and talk about how to choose the perfect drive for you and even check the health of the one you've already got.
All right, first things first. Why are we even talking about an SSD wearing out? I mean, unlike those old school mechanical hard drives, there are no moving parts, right? They should last forever. Well, not exactly.
And here is the absolute key. Just reading data from your SSD barely does anything to it. But writing data to it, saving a file, installing a program, downloading a game, that process physically degrades the little memory cells inside. That's right. Every time you hit save, you're using up an infinitesimally small piece of your drive's total lifespan. It makes every SSD essentially a consumable product. This whole thing is called the erase/rewrite cycle. The best way to think about it is like this. Imagine a memory cell is a tiny, tiny cup. Now, to put new water into that cup, you first have to dump the old water out. Every single time you do that, erase and then rewrite, the cup gets a microscopic little scratch on it. Now, after thousands and thousands of cycles, those tiny scratches add up until the cup just can't hold water anymore. That's literally what happens inside your SSD.
Okay, so if every SSD is slowly wearing out, how in the world do we measure it? Well, that's where two really important, and let's be honest, kind of confusing acronyms come into play: TBW and DWPD. Let's clear these up right now.
First up, we've got TBW. That stands for terabytes written. This one's the most straightforward. It is the grand total, the absolute maximum amount of data the manufacturer guarantees you can write to that drive before it's expected to start failing. The car odometer analogy here is perfect. It's the total mileage your drive is rated for over its entire life. So if you see a 600 TBW rating, that drive is built to handle 600 terabytes of data being written to it. Simple as that.
And then we have DWPD, or drive writes per day. Now this one is a bit different. It's a measure of the rate of endurance. It tells you how many times you could completely fill up the entire drive with new data every single day for its entire warranty period, usually 3 or 5 years. So if TBW is the car's lifetime odometer, DWPD is more like a rental car's daily mileage limit. It's all about how hard you can thrash it, day in and day out.
So to put them side by side, TBW tells you how much data you can write in total. DWPD tells you how often you can hammer it with writes every day. This is exactly why you almost always see TBW on consumer drives for people like you and me, while DWPD is a make-or-break spec for intense enterprise stuff, like servers that are just constantly writing data 24/7.
Okay, so we get how endurance is measured, but why does one drive have a massive TBW rating and another one has a tiny one? Well, to answer that, we have to look at the actual physical memory chips inside the drive. This table right here basically explains the entire SSD market. It all boils down to how many bits of data get crammed into each individual memory cell. At the very top, you have SLC, or single level cell. It stores just one bit, it is incredibly fast, incredibly durable, and incredibly expensive. But as we go down this list, we're stuffing more and more bits into the same physical space. This is great for making drives bigger and cheaper, but it absolutely hammers their endurance. All the way down at the bottom, QLC is the cheapest, but its cells can only handle maybe 1,000 write cycles before they give up. And that brings us right back to the beginning. Right back to our original question about why one drive costs $50 and the other costs hundreds more. And there it is. That's the answer. When you buy an SSD, you're not just paying for storage capacity, you're paying for endurance. That cheap $50 drive, I can almost guarantee you it's using that lower endurance QLC memory. And that pricey $250 drive, yep, it's built with the more durable and way more expensive TLC or even MLC memory.
This really makes the relationship crystal clear, doesn't it? On one end, you've got QLC. It's super affordable, but it's not built for a life of heavy writing. On the complete other end, you have MLC and SLC. Yeah, they cost a premium, but they are built like absolute tanks for the most extreme workloads. And right there in the middle is TLC, which, for most people, is the real sweet spot. A great balance of cost, speed, and endurance.
Okay, so we've got all this knowledge now. How do we actually use it to pick the right drive? Look, it is not about buying the most expensive thing you can find. It's about matching the drive's endurance to what you're actually going to do with it. Let's be real. If you're a casual user, you're browsing the web, checking emails, streaming videos, your write load is incredibly low. Do not waste your money on some high-end monster drive. A budget-friendly QLC or TLC drive is absolutely perfect. Honestly, the chances that you replace your entire computer because it's old are way, way higher than you ever wearing out one of these drives. Okay, but what about gamers and developers? Now, the story changes a little bit. You're writing a lot more data, installing huge games, compiling code over and over, you get the picture. For you, it's worth stepping up to a good quality TLC drive. It gives you that perfect balance of wicked fast NVMe speeds and really solid endurance, all without totally emptying your wallet. And finally, we have the heavy hitters, people running servers, 24/7 video surveillance systems, or intense databases. These are what we call write-intensive tasks. And here, endurance is literally everything. You ignore the price tag and you focus completely on getting the highest TBW or DWPD rating possible. You're looking at enterprise-grade drives with MLC or maybe even SLC memory. Because for these jobs, failure is just not an option. All right, so you've chosen your drive, or maybe you're just getting a little curious about the one that's been sitting in your machine for a few years. How can you actually check in and see how it's doing? Let's find out. You'll be surprised how easy this is. You can grab a free tool. A really popular one is called Crystal Disk Info. Just install it, run it, and it's going to show you a ton of information about your drive. But you really only need to look for two things: the overall health status, which is usually a percentage, and a field called total host writes. That tells you exactly how much data you have written to that drive over its entire lifetime. And hey, if you really want to geek out, you can even estimate your drive's lifespan with this simple formula. You just take its official TBW rating, turn it into gigabytes, and then divide that by how much data you figure you write every day over a full year. It's a pretty cool way to see just how much life you really have left. So after all that, what is the big takeaway? It's this: for the vast majority of people, your SSD is not going to just randomly die on you. Modern drives are tough. The real power you've gained today is knowledge. You don't have to guess anymore. You can read the specs, you can match a drive to your actual needs, and you can even keep an eye on its health over time. And that's pretty much it. So, now that you're armed with all this info, I've got one last question for you. What's the very first thing you're going to go check on your own SSD? Are you going to look for that health percentage, see your total terabytes written, or maybe even calculate how many years you've got left? Thanks for tuning in.